It is the number of elements. Bar A bar means the number of elements in it. Right?
Okay, so it'll be 0, 1, 2, 3, 4, and then 4 minus 3, 4 minus 1, or what?
No, the number of elements, not the index of the last element. So in the case of A, like what we have drawn on the board, bar A bar in this case would be 5 because there are 5 containers inside the box.
Okay. So
Okay.
if you actually add that to you do that to the first one also? Because it's 0, so
This is the number of elements, so when you count the number of elements, it is 5. The index or the number of the last element inside this box is bar A bar minus 1, and that's because we are counting from 0. Okay? Good questions. Those are things that you guys really need to clarify like from day one, because otherwise it will just come back and bite you. Any other questions regarding the symbols and the meaning of those symbols when we deal with arrays? There are basically only 2 new symbols that we introduced. One is the square bracket notation, which specifies the index, and the other one is bar A bar, which is basically saying how many things do we have in array A. Are we okay so far? Okay. If we're good so far, then we can move on and talk about certain algorithms. Okay. So we'll just go ahead and take a look at this one, and I will give you a trace of how do we represent an array in our usual way of tracing. But first of all, we'll just take a look at the algorithm itself, and I'll try to explain what it does. I is no different from our usual w, x, y, z variables. I is nothing more than a variable, but I choose to use I in this case because it represents an index. Okay? But other than that, it is just a variable. It is an integer variable that is capable of storing an integer value. While I is less than bar A bar means that as long as I has a value that is less than the number of elements in an array A. Okay. And since I don't know what array we are talking about, I cannot tell you exactly what is bar A bar, not at this point. A bracket I gets 0, which means I am using I as an integer value to specify which container inside the box should be initialized to 0. Are we okay with this? And then I add 1 to I. Remember, I is not special. I is just a variable that contains an integer value. So I can do this just like I can do x against x plus 1 all the time, with our existing code. And then we have end while here. So what we want to do is to trace this algorithm and find out exactly what does it do and how do we represent it in a trace. So we'll go ahead and open up a new spreadsheet. Format the hard drive. Where did that come from? Did you see something that I did not? Okay, let me find the. There we go. Okay. All right, there we go. So I'm just going to copy the algorithm first, and then we'll trace it. So I get 0. Okay, how come there's no... Okay, I space A. That's not right. I think I see what you're talking about. It's still recording. Something is not right. No, I'm referring to the fact that OpenOffice seems to have forgotten that I have turned off autocorrect. That is not good. Okay, let's see. I get... Okay, maybe I just never turned that off. It's under autocorrect. autocorrect options. Go to options, use replacement table. Okay, so somewhere in the replacement table is I getting converted from lowercase to uppercase.
Right there.
Right there. Get rid of it. That's annoying. Okay. So now I have I gets 0. While I is less than bar A bar, do A bracket I gets 0. I gets I plus 1. And while do the usual indentation. Add line numbers. Fix the width. And we're good to go. All right. So the first question is, how can I trace this algorithm not knowing the actual size of the array? The answer is, I cannot. So the first thing we have to do is to say, okay, tell me how many elements there are actually in the array. So you have to make certain assumptions in this case. So in other words, we have the usual comments, line number, and definitely the variable I. But we also need to know what is the array A. How many elements are we talking about in array A? The way I usually do it is I would just say this is array A, and in this case, let's just say it has 3 elements. If array A has 3 elements, I would say array bracket 0 is 1 column, A bracket 1 is 1 column, A bracket 2 is a 3rd column. Okay? So collectively, these 3 columns is an array. But each element inside an array is an individual variable. It can have a value that is independent to its neighbors or any other variables in the program. Are we okay so far? Okay, let me just change the size a little bit so we can see the whole picture a little bit better. You can see that the number of columns we have in this program is 4 columns. We have 1 column for I because I said that I is just a regular variable. Array A has 3 elements in this case, and that's why each element has its own column, because one element of an array is just like a variable on its own that has a funny name. So in this case, column D has a funny name of A bracket 0. Column E has a funny name of A bracket 1, and the same for column F. Are we okay so far? That we need 1 column per element in an array. Okay. So with that in mind, do we need to make any assumptions about the values of each element in the array? What is the first access or the only access to the elements in this code? If you look at the pseudocode here, are we reading or are we writing, updating the values of the elements? We're always overwriting. Are we overwriting the value that depends on the element itself, or are we overwriting it with something that has nothing to do with the existing value of the element? Nothing to do with it? So that means we don't have to assume anything. So that's why in this case, the precondition can be just question mark for every single column, because it doesn't matter what they used to have, we'll overwrite it all with something else. Are we okay so far? Are you guys starting to see that each element inside an array really behaves just like any other variables? Okay. So now we start with line 1. Line 1 is easy. I gets initialized to 0. Because I, remember, is just a normal variable on its own. Then we move on to line 2. Line 2 is evaluating I is less than bar A bar. Can someone tell me whether it is true or not? What is bar A bar in this case? Not absolute value. Remember, number of elements. How many do we have? 3. Bar A bar is 3. Because in this case, bar A bar is the number of elements in array A, and as you can see here, array A only has 3 elements. Is 0 less than 3?
Yes.
Sure. Okay, so it is true. Yep.
Was that given?
Yes, I have to give you at least this much in order for you to get started with the algorithm. Because if I don't tell you how many elements the array has, there's no way you can proceed and actually do it.
So bar A bar is equal to 3. The first
In this case,
one
yes.
will always be like A bracket 0.
The index of the first element is always 0.
Okay.
Yep. So now we move on to line 3. Line 3 is actually the fun one. So I'm going to highlight this line just to indicate this line is actually somewhat interesting. So you have to kind of pay some attention to this line here. Line 3 is an assignment statement because we can see the left arrow symbol. The right-hand side is not any problem because the right-hand side is a constant 0. So we are evaluating the expression 0. The result is 0. No big deal. The left-hand side seems a little bit strange. It is not the usual I, X, Y, Z, and whatnot variable. In this case, it is A bracket I. So what do we do? What is I?
0.
I is 0. So A bracket I, at least at this point of time, is the same as A bracket 0. Do we know what is A bracket 0?
No.
No, do we know where to find it? Okay, A bracket 0 is column D. So that's why, on line 3, at least at this point, we update column D so that it is going to go from a question mark to a 0. Are there any questions at this point? Because this is actually pivotal. This is the important part of using arrays. Yep.
So why are we just only updating that one?
Because I
I
only
is
has one
0.
value. I has a single value of 0.
Okay.
So when you specify A bracket I,
Okay.
it is the same as A bracket 0.
Okay.
And A bracket 0 refers to a single column, and that's why only a single column gets updated. The next line, line 4, is pretty typical stuff. We add 1 to the variable. I goes from 0 to 1, no big deal. We go back to the beginning. I is less than bar A bar is true because bar A bar is 3. I is only 1 at this point. Then we go back to line 3 again. What do we do this time? We put a 0 into which column? Column E. Okay? Very good. Now this is important. This is also very important. I would say this line or the trace of this particular line is actually even more important because you can see that we are still executing line 3. We executed line 3 of row 6 of the trace. We executed line 3 of row 9 of the trace. And yet, a different column gets updated because I changed. Okay? It's all because I got changed from 0 to 1. So A bracket I is now referring to a different column.
A different container in the array. A bracket I is referring to a different container in the array.
Exactly, because I got changed. So now we can go for the last iteration. This time, what do? We're back to line 3. Which column gets updated this time?
F.
Column F. Very good. So the same line of code at different times of the trace updated a different column. It's all because I got changed, and I is inside the square brackets. It controls which element are we updating in the array. Okay? And this part, this is really, really important in terms of the understanding of indexing and arrays, because this is really the core of what an array can do. The rest is really just, algorithms that can exploit